Hi Math 2E. Let's look at a few graphing problems on page 18 of our packet. So first of all, I need to know my roots or my zeros, my x-intercepts before I can graph. I have to consider any multiplicity. Are there any bends or are there any bounces? I need to know what my y-intercept is, and I need to know what my end behavior is before I can graph. So this problem, if x minus 1 is my factor, then x equals 1 is my root, and this has a multiplicity of 3 because it's to the third power. It's an answer 3 times. So yes, I'm going to have a multiplicity. I'm going to have a bend at x equals 1. My y-intercept happens when I substitute x equals 0 into my equation. So this would become y equals 0 minus 1 cubed. That'd be 1 cubed, negative 1 cubed, which is negative 1. So my y-intercept would be 0, negative 1. And my end behavior, well, this is degree 3 with a positive 1 leading coefficient in the front. So that would be down on the left and up on the right. And I know that because I've memorized those from page 16. So I'm now ready to graph it. My x-intercept is 1, my y-intercept is negative 1. I've got my end behavior on here, and I need to bend as I go through 1. So I'm going to come down towards my x-intercept, and I'm going to bend, so creating like that concave up look into a concave down look, catching my y-intercept at the same time. And this would be my graph that goes through 1 on the x-axis, also goes through negative 1 on the y-axis, and shows having a bend at x equals 1. So let's take a look at 1b. Sorry about that. My roots would be x equals negative 2 with a multiplicity of 2 and x equals 1. So yes, I'm going to have a bounce at x equals negative 2 because that's a multiplicity of 2. My y-intercept would be 2 times 0 plus 2 squared times 0 minus 1. That's giving me 2 times 4 times negative 1. It looks like it's negative 8. So I'm going to go put a dot on negative 8, my y-intercept. I'm going to put a dot at negative 2 and a dot at 1 on the x-axis. And my end behavior, so let me put a 1 behind this linear parenthesis. So I literally can add my exponents of 2 and 1 and get degree 3. Or I can think about boxing these out. If I do x plus 2 times x plus 2, I'd get an x squared polynomial. And then if I'd box that out with my x minus 1 in a 3 by 2 box, I'd get an x cubed polynomial. My coefficient is a positive 2. So that means my end behavior would be down on the left and up on the right. So let's come down through my 1, and there's no bounce or anything. And my y-intercept is not going to be my min. If you see, from negative 2 to 1 are about 3 units apart, and halfway would be negative 1/2. So I'm actually going to go through my y-intercept, go a little past that. And now I'm going to turn around and come back up towards my negative 2. But remember, I have to bounce here. So I'm not going to cross. I'm going to just turn around and go back down. And that would be my graph. So let's go to my roots would be, so next page, and take a look at 2 and 3 here at the top. So on number 2, this particular problem, they don't give me the guidelines, but I'm still going to do the same things I was doing. So I'm going to find my roots, x equals 2 and x equals negative 1. There is no multiplicity, so I'm not really going to be thinking about that. My y-intercept would be negative. If I plugged in a 0 for x, I'd get negative 2 times 1. So that's given me a 2. So my y-intercept would be 2. My x-intercept is 2 and negative 1. And my end behavior. So this would be a degree 2 if I multiplied them. And I've got a negative leading coefficient. So then my end behavior will be down and down. and this is really just a parabola. And I know that my y-intercept is not my max because my x-intercepts are -1 and 2. They're 3 units apart, so really 1/2 would be more in the middle. So when I go to draw this, I'm going to come up through my x-intercept. I'm going to go up a little past sorry, it's so hard to draw with my Apple Pencil. I'm going to come up a little past my y-intercept to have a max, and I'm going to come back down through. I am having some trouble drawing precisely with my Apple Pencil. This graph should be smooth. Polynomials are smooth curves, so my graph looks really rough. It should really be more of a smooth curve. Sorry about that. Okay, let's take a look at number 3. My x-intercepts are x equals -7, x equals -1, x equals +5, and x equals 3. So I'm going to just go put dots at those. And then my y-intercept, multiplicity. There's no multiplicity, so there's going to be no bounces and no bends. My y-intercept is if I put a 0 in for all my x's, I'd get 7 times 1 times -5 times a -3, and we're going to get 105, which is really kind of crazy and really far off the graph. So why don't we just put a dot up here? I'm going to change my color to red. We're just going to put a dot up here and call it 105. It's just up higher than my y-axis. I mean, it's just really far up there. It's just kind of crazy. I can't really do that anyways. And then lastly, my end behavior. Well, this, if I multiplied all 4 of these polynomials, I would get an x to the 4th. So this is degree 4 with a positive leading coefficient. So I'm going to be up for my end behavior. So I'm going to be coming, so I'm going to be ending up. So I'm coming down through my 5. I'm going to stop and turn around and go back up through my 3. And now as I go up towards my y-intercept, my 105 really isn't going to be my max. Halfway between 3 and -1 is really +1. So I think that my max, a good guess, if you will, would be in the middle. So I'm going to go up a little farther than my 105 and turn around and come back down through my 105. Come back down through my -1. Go about halfway between my -1 and my -7. Turn around and come back up and finish going up. So let's take a look at number 5. Number 5 actually doesn't have any multiplicity. Sometimes students get confused with that x squared. So let's look at this one. My roots, I get x equals -2, x equals +3, and x squared minus 2, when I set it equal to 0, gives me x squared equals 2. When I take the square root of both sides, I get x equals plus or minus the square root of 2. Now that's a little difficult to graph. I don't really know where that's at. So let's do my square root on my calculator, and I get 4.14. So it's roughly 1.5 if I want to think about graphing it on here. So I'm going to put a dot at -2 and a dot at 3, and then I'm going to put a dot at about 1.5. And another, oh, those dots are close together. That's not going to be easy on here. So I need to think about any multiplicities. There are none. None of my 4 roots are repeated. They're all different numbers. My y-intercept, when I plug a 0 in, I'm getting 2 times -3 times a -2, which is giving me a positive, is that positive 20? Or no, positive 12, sorry. Positive 12 as my y-intercept. So I'm going to put a dot up here at 12. And then my end behavior. So now be careful. If I multiply all of these together, I'd get a degree 4. There's a couple ways to think about it. I have 4 roots, so obviously it has to be degree 4. Or my x times x, my first 2 parentheses would give me an x squared trinomial, and x squared times x squared would give me an x to the 4th leading term. Again, my 4th degree, positive. So I know my end behavior is going up. I know it's positive because there's a positive 1 in front. So let's do this. Let's come down through my x equals 3 intercept, turn around, come back through my 1.41. Now, my y-intercept of 12 might be my max. I say might be because, again, we're just guessing. I don't really know where these maxes are. I just need to kind of go halfway and turn around. But 0, x equals 0, is halfway between plus and minus 1.4. So I am going to just turn around at my y-intercept, come back down through, turn it around, go back through my fourth and final x-intercept, and I get this graph. Try the other few problems on your own and then check your answers in the folder. Thank you.